Hello, my name is David Ackerman, student number 220-310-629, and this is my MEC 2302 Dynamics Assignment 9. Let's get started. So this is the question that we're given, the whole scenario, the question. Here is the diagram that we're given, and in question A, and then another diagram, and then question B. So this is the givens that were given, where the mass of block A, the mass of the spool, the radius of gyration, the spool inner radius, the spool outer radius, which we calculated for, and then the system at rest. The system starts at rest, and the unknowns are the velocity at a true at 8, which is V8. Here are the schematics where this is scenario one, this is scenario two. This is the analysis where at first we have to start with the conservation of energy, where T represents the kinetic energy and V represents the potential energy. So because the system starts at rest, T1 would be equal to 0. And because it also starts at the datum, V2 is also 0 because H is 0. The height is also 0. So 0 equals T2 plus V2, and then we substitute all the known the T2 plus the variable as an equation, and the V2 as that whole equation. So we substitute the angular velocity for velocity A divided by the radius, which is given by this formula right here. And then we substitute that here. We throw T2 to the other side and make it negative. We substitute all the known values. So the mass A, gravity, the height 2, which is negative 0.5 because it's moving downwards. Um, the variables here, and we're solving for VA. 2, so VA2. So that this is a variable that's squared, just clarifying it. And substituting here, we are simplifying everything, simplifying, and here we're solving for VA2. So the VA2 would be equal to 1.289 meters per second downwards, according to all the calculations, with the given values and constraints. So question B is to make the process of lowering the block A easier and more user-friendly, we can improve the current system by adding tools such that reduce the physical effort needed. For example, using a motorized winch or unit with the speed control would let users load the block more smoothly and safely by just pressing a button instead of pulling the rope, which would make it more reliable because it's a more mechanical system, whereas it would decrease human error if we keep it as a human that would be lowering the rope. Another option is adding the hand-operated brake or lever that would give the user more control with less force, especially if it has a comfortable grip. So it would allow the user to instinctively brake whenever they feel like it instead of having to lower the rope themselves. These changes would make the system safer and easier for everyone to use, especially the people that may not have a lot of physical strength, for example, like younger or older audiences. By making the equipment more ergonomic would help create a more inclusive and fair work environment, whereas ta these tasks could be more accessible to everyone that's available. This has been my assignment 9. Thank you so much for watching.